All right, good morning, guys. So we are going to be modeling some bearing holders for our foosball table. So I'm going to show you guys what that's going to look like and how this is going to impact the way that we design this foosball table. So why don't you log in and get your Onshape account pulled up, and we'll get started in a minute or so. All right, so hopefully now you have this opened up. I'm going to model the dimensions of the bearing that we're going to be using. So we want to use a 3/4 inch shaft. Now, most foosball rods seem to be 5/8, but I think that I want to make ours better than what you can buy. Otherwise, we would just buy one, right? So one thing I've noticed is that on foosball tables, when there's a lot of activity going on, after a while, those rods start to bend. So if we can get some stronger, thicker rods, that might help the problem. So we're going to do a sketch here. We're going to do it in the front plane. And I went over here to McMaster Carr and I found the needle bearing that I want to use. And I can come over here and I can save it as a 3D step file and I can upload it. But this part is really simple. It just has an ID of 0.75 inches. It has an OD of 1 inch. And then it has a depth of 1/2 inch. So we can realistically just model out really quick in our CAD software, because when we have a part, when we import a part like this is going to take up a lot more of our RAM, our memory, because it's modeling each one of these little needles, it's modeling all the different faces, whereas all we really care about is the dimensions for when we place this thing. So this can allow our program to run a little bit smoother while we are modeling. So I'm going to start out with a circle on the origin. And I know that we're going to want 2 circles like that, and then I can always just come back and dimension them. So the ID is going to be 0.75. We're going to come across here. This is going to be 1. All right, so now we can come here and we can extrude this. And this is going to be 0.5. And there we go. That is our bearing modeled. So I'll let you guys get to this point. When you have, please go under your participants area and check yes. So I know that you've completed this. All right, if you have not gotten to this point, I need you to check no next to your name. I need to make sure that everyone knows how to do this, so I'm not waiting for no reason. So you just go under participants and you should see a bar that says yes, no, go slower, or go faster. You just need to check, if you're not done, you just need to check no. And if you are done, you need to check yes. I need to see this from everyone because I don't want to be waiting for someone and they just don't know how to do it. Jack, Jaden, and Jamie, I haven't seen your responses. And Ryan, I haven't seen your response either. No, this is in the Zoom meeting. When you go under participants, you click on that tab in your, like where it says like share or some other options that you have. You click on participants and there's a bar that says yes, no, go slower, go faster. And that way I can get feedback during the meeting. Thank you, Jack. All right, so all right, so now we need to make the housing for this. So the reason being we need to make a housing is we're not going to press this into the side panel where the rods kind of go through. And that's mainly because this is 1/2 inch and it would look really, really dorky if it was sticking out of the material, right? And we're not going to do 1/2 inch material because that's so expensive and so unnecessary. What we're going to do is we're going to make it thicker where we want it. So what I'm envisioning we'll do is we'll have, you don't need to do this part. I'm just going to model it for demonstration purposes. We're going to have this be, part of our body here. And we're going to make this hole just slightly bigger, something like that. And that way, our part, I'm going to extrude this, like it's not going to be the actual shape of our foosball table, but if this was a small cross-sectional view of that area, this is probably going to be 0.25. We're going to reverse that. So you can see here, this is probably what it's going to look like. The hole here is going to be used for locating it rather accurately, but it's going to have a little bit of slop you can see right there. And then we're going to make some 3D printed parts that retain the bearing on the backside and then that bolt in to the face here. So what we're going to need to do is design a holder for this that will not only hold the bearing, but also allow us to mount it into the sidewall here. And then we'll take that bolt hole pattern and include it on our outside piece that we manufacture for this. Another option that we could do, but I want to avoid, is if we didn't want to 3D print this bolt-on thing, what we could do is we could So let's just say that this is our big sheet right here. You know, if we look at, you guys have all seen a foosball table, so there'd be holes all the way down here for each rod. What we could do is we could come back and make little parts like this that have the hole in the center for the bearing. And then you could take that and we'll make this 0.25. And you could just do a lap joint and weld around here and then press the bearing through, and that would take care of that. But there's a few issues that kind of come up with this design. The first issue with this design is that this bearing is now not really serviceable. If in the future, at any given time, you needed to replace this bearing, it'd be very difficult because this is pressed in, okay? So you're using the material to restrain this bearing, and that just isn't the best way to do that. It can be done in certain applications, but the other thing is that we have to think about is we've got this sheet that is probably going to go about 4 feet, okay? And every time you weld, you're going to have some distortion. And when you're trying to align bearings and whatnot, you really don't want any sort of distortion. So the more welding that you put on it, the more wacky it can get, and you really just don't want to do that. So I would say that if we had a bolt-on bearing retainer, that would probably be better for our needs. But this is a different way you could do it, and depending on the application, you know, it might be fine. Well, Carter, we are going to make it out of aluminum, and we might even do some weight saving methods, you know, instead of just having a solid thing there. But that's for another day. So what we're going to do now is we're going to take a look here, and we're going to sketch on this face right here. Actually, I don't think you guys have that, so we won't put a sketch there. I'm going to get rid of that, and we'll just sketch on the face of our bearing here. So we'll do sketch, and we'll click on the inner face right here. So we know that this is going to go in about 1/4 inch. We might even do an 1/8 inch. We'll see, but I think making sure that those walls are sturdy is more important than light. Okay, so now that we're sketching on this front face, everything's going to go back like that. We're going to grab a circle tool and go on the center origin. We're just going to pull it out like that. We're going to dimension this circle. We're going to do 1.05, and we'll do 03, just so it's slightly oversized. Maybe let's see. Maybe 102. There we go. So that's going to be the ID of our bearing holder. Then what I'm going to do is I'm going to grab another circle. And actually, you know what? Let's not do that. Let's use a different tool. Let's go and use offset. Okay, so we're going to do a 1/4 inch offset. So that way we have a 1/4 inch of width here. The offset tool you can see is right here, or you can also press O for offset. All right, now let me know if you are at this point by checking yes in the participants bar. All right, so now we're going to create an offset plane. From here, we're going to make this 0.25. We're going to come and sketch on plane 1. So we'll select plane 1. We're going to put a circle on it. We're going to make this circle 0. .76, and that way it has some clearance for the rod, but it still retains the bearing. We're going to come in and make another circle on center, and we're going to go right there, 1.02. And now that we've done that, we can loft from here to here. Actually, that's making an issue. So we'll take this and we'll just, we know that's going to be our center hole, so we can just deal with that later. So let's come back into this one. And we're going to loft. Just take this and delete that one. Oops. Oh, that's a problem. All right, so we'll just we'll go back. And that's okay. We'll select plane 1. Actually, I think we're going to do this a different way. We're going to restart from here. we're going to put a sketch. We're going to sketch in the right view. I'm going to just draw a line out here for a reference line. So we'll make that a construction line. And then we'll come up here. We know that the diameter of this is 0.75. So we're going to dimension this line to be 0.375. And then we're going to come out and we're going to dimension another line to make this, we're going to make this 501, 0.501. Now I've got this 0.501 and this 0.375 here. I'm going to take these and I'm going to dimension these to be 0.25 apart. And actually, let's dimension this to 0.376. Then we're going to come and dimension off this point, and we're going to make that, let's see, 0.75. And we're going to dimension this from this to also be 0.25 away. So I just put a horizontal constraint to make those the same height. And we'll use our 3-point curve to go like that. Oops. I'm going to draw a line from here to there, and then we'll drop this down. We'll make sure that this is 0.25. And then we'll come up and we'll make a line from the bottom here, and we'll actually add that line right there. We can just go across like that. All right, so this, I believe, is the shape that we want. So let's see if that works, and then we'll go back and revisit it. Actually, I don't want to extrude that. Let's go revolve around this axis here. All right, that looks kind of like what we want. So you can see right here, we'll turn part 2 off. And we'll go back over this because I definitely went fast through it. So you can see that we have a shoulder to retain the bearing. If we went to measure this, if we went from here to here, that tells us it's 0.25 inches, which is exactly what we need. So this is going to slide over the excess of the bearing and be retained by this, but the rod can still go through it. We still have to add some bolt holes to this. That won't be too hard. So now I'll turn part 1 on, and we can see right here, I want to translate this. All right, and there we can see our part is together and mated correctly. So that revolve, the issue I was having with the loft is that since we did the offset, I couldn't delete the inner ring because the outer ring was determined by the offset. So I wanted to try to do this with lofting, which we could have done, but revolving it seemed to be the easiest way to do it in one single sketch. So let's go take a look back at the math that I had to do to create this shape, because you have to think about it in a kind of abstract way for a second. And then once you see that, then you can start making your part. So when you revolve something, you take a geometry, an enclosed geometry right here, and then you revolve it around some axis, okay? So that's why we created this first axis right here, because I knew the first thing I want to do was revolve it around the center, since it is a circle. The next thing that I did was we measured up to here, which was going to be how the bearing was going to be retained. And then this is going to be the depth of the bearing. This is going to be the shoulder width of the bearing. So that's going to be the, if we look at the width of the wall, that's going to be from the top of here to just about the edge here. I did it a little bit less so that there was no interference for what was passing through there. Now we can start seeing the dimensions here. Then we went over, so this is going to be the wall thickness of the part. This is going to correspond to this part right here. And then we just have an arc to connect that. And then this is going to be the wall thickness of the shoulder that goes over there. I think most of the drawing numbers here are visible. Let me try to.
Schwartz, how'd you make that first line a construction line?
Let me show you. Let me grab here. Trying to pull this over. There we go. Make that easier. So to make any line a construction line, you can draw it and then you come up here and you can either click Q on your keyboard and then that'll bring you into the construction menu, and then I can come and make this. I can select it, hit Q, and that will make it a construction line. That also doesn't necessarily have to be a construction line. I just do that because when I first started doing this, I wasn't sure whether I was going to need that line as an actual line or a reference line later. So I just made sure it was a reference line to start with. All these lines could be reference lines as well, but since they don't connect any geometry, it's not enclosed, it doesn't really matter, but
Thank you.
I could do that. So here pretty much is the blueprint for how to sketch this out. I'm giving you all the dimensions here. Would anyone like me to go over a process here or any move that I made that you're not understanding?
Okay, how do you like revolve the final shape?
So once you have your final shape, you're going to come out of your sketch. So just click that little check mark. And then revolve is going to be this one right here. It's to the right of your extrude. So you click on revolve and then this menu comes up. And so it's going to ask for a solid. We want a new solid. So you're going to select this sketch area here. Oops. So it's asking me for, oh, I might have made, there's an issue. I made a construction line. There we go. So we're going to edit revolve one. You can see right here, it's asking me which faces that I want to do. And as long as you have this filled in, you can select this geometry. And then it's asking for the revolve axis. So that first line that we drew down here, it's going to revolve around that axis. So what's cool about the way that we designed this is that we designed all the features in our part in one operation. So we designed that shoulder, we designed this hole, we designed the the big OD hole, and that is really nice because if we had tried to do this in an extrude manner, that would have been multiple steps. So I'll go back to the sketch so you guys can see the dimensions here. All right, please respond in the participants area if you are at this point. All right, for those of you who are not there, I need to know why, so that we can problem solve and figure out what we need to do to get yours to work. So please, in the chat area, write to me what you need, what information you need, so we can do that. So for this part, what I think would work best would be if we retain this with a heat insert. So this is going to be 3D printed. We can have a hole in the print here, and then we can heat up a brass threaded insert and press it into the face here so that we have metal threads that we can use. So what we're going to do is we're going to sketch on the back side of our part. We're going to put a hole. We're going to go on center for the first one. And that hole diameter, I think we're going to, oops, we're going to make these, we'll probably use a 832 screw. So these are going to be 0.1875, 3/16 of an inch. And I'm going to drag that back down. Actually, we're not going to dimension that. What we're going to do is we're going to draw a line from the center here to here. And we're going to draw another line from the center here to here. And we're just going to come over and we're going to use our equal tool. And we're going to make sure that these two lines are equal. And that's going to lock that in to be this on center there. So now we can come and we can revolve this around. I want to do 3 holes because 3 holes defines a plane. You're not going to get any wobble in it. So we're going to come around and we're going to go on the circular pattern. It's just right over here on the patterns. It's under the linear pattern. We're going to select our circle. And we're going to select any other circle around here. Actually, no, I want to deselect that. And we can select how many we want. So it senses that I want to do around here, and this makes it all equidistant. And I can just right click and I can have these holes here. So now what we could just do is we can just take our extrude function and we'll select these holes. Oops. And we'll do remove. And we'll just go through here like that.
Wait, how did you get those 2 holes?
So we'll go back into sketch 2. We'll edit it. So I drew the original circle right here, and I centered it using 2 lines going from the center to here and center to here, and then I made them equal. So that means I don't have to dimension anything. It'll always be the same. So even if I make this circle bigger in another sketch, this will always remain on center. And then I came over here and I used the circular pattern tool. So when you select the circular pattern tool, you select something that you want. This doesn't have to be a circle. It just means that whatever shape you want to do, it's going to revolve it in a circle. So this, it's not like you have to use the circle revolve to revolve a circle. It's just going to do it in a circular manner. So if I grab this, you can see it's starting to do it on center here. And if I wanted more holes, I could just adjust the value here. See how it says 3x? I just come here and type 4. If I wanted 4 holes, or however many holes that you wanted, I just want 3, and they're going to make them equidistant. Then I just right click and it's there. Then I just drew them out. You can see that here. So now we pretty much have a part that is ready, and we'd be able to bolt this on. And so all we have to do now is when we manufacture our foosball table, we're going to sketch on this surface. I'm just modeling the foosball table like I had earlier. All right, so that's what this would look like. And we'll probably make something that goes over this side too, just so you just don't see that bearing. It'll probably line up with these holes as well that we have here. So that retains it. And what we could do is that if we decide that we have the material to do so, we could actually make this 1/8 of an inch and then make a similar looking thing to this, but a smaller scale one that retains it over here. But we can make those design decisions later. So when we have this all said and done, there's going to be 4 of these going along each side. And there'll be 4 on the other side. Actually, no, I think there's 8. So there's 4 on each side of each team on each side. So there'll be 8 of these going down the length of it. All right, so I'm going to show how to do the circular pattern once again. So let me hide part 3. So what I did was I came into sketch 3 here and I drew a circle right here. Actually, no, I think this is sketch 2. Yeah, sketch 2. I drew a circle and I made that circle 0.1875, but it'll probably round up to 188, which is fine. And then once I drew that, I drew a line here and a line here that connected this inner ring to this inner ring, and then this outer ring to this inner ring. And once I did that, I used the equal constraint, and then that made it so that this circle is always going to be in the center here. I didn't have to dimension that. And then from there, I used my circular pattern tool. And then once you do the circular pattern, you can select that. And then it should be on 3 already, and then you just have to right click and it'll make it again. Now once you do that, you'll get out of your sketch, and then you'll have those circles there, and then you just use the extrude, remove, and you should have holes in your part now. So Carter was asking, how do you move the bearing into the holder? So the way that I did that was, let's hide part 1. Oops. Let's hide these planes as well. Okay. So you come over to transform, and instead of doing the XYZ, I did the transform by mate connectors. And you can select this inner ring here, and then you turn on part 1, and then you select the matching contour line, and then it should align them. So I'll show that again. Give me a second here. I'm going to get rid of this transform. So now you can see the parts are not aligned correctly. So I'm going to hide part 1. And I'm going to go transform. And I'm going to do transform by mate connectors. I'm going to come in here. Oh, it's not letting me select that. So let's change this up. Let's turn off part 2 and turn on part 1. All right, we'll select that. Turn on this. Well, it seems that there is an issue here because I had it shown here before. is already located. You might just have to, instead of using that, you'll probably just have to do it by XYZ and moving to align it. But it doesn't really matter because everything that we've modeled, if you have all those same dimensions, it should be just fine. And we're not modeling this now because what we'll eventually do, because right now we're in the part space, we'll go over to the assembly space, and you can put all sorts of stuff in here. So I can go in and grab this part and that part, and we can move them all around in there. And that's how we're actually going to assemble this model. What's actually cool about this is I can go into other documents and grab other parts. So like, for example, I can go back and grab our foosball handle. Actually, I think this is someone else's. So now I can bring in part 2. You can see I've got my handle. So that's how we'll end up putting everything together. All right, so I'll post in Schoology the YouTube channel link. So I've been live streaming all these meetings recently, and that's allowing me just to post the meetings automatically if they're just saved there. So you can subscribe to that channel, and then you can just always have that, or you can just go to the Schoology link, whichever one works best for you. So I think that that's going to wrap up class, and I'll see you guys tomorrow. I want to remind you guys that the superintendent is coming in tomorrow morning, probably around like 8:55-ish. We're going to be working on this foosball table again tomorrow. This is kind of like our class project that we're going to be working on. So once we get a few parts going, we're going to show how to operate the CNC plasma cutter, how to do some 3D printed parts in the lab. So I think we're going to start getting some more hands-on work going soon. All right.
Cool.
All right. I'll see you guys later. I think most of you guys have a class coming up soon.
Have a good day.
You too, Joseph.
Mr. Schwartz.
Hey, Carter.
I don't think I've told, I definitely haven't told you yet, but I have looked into doing a running start program, and I think I found one that I'm going to do.
Oh, nice. What do you think about doing?
So it's at Ren Tech.
Mhm.
It's called like Option B technical program.
Mhm.
So it's basically, I get to go there to get my associates, and instead of doing high school anywhere else, I get my diploma through them as well from getting my associates there.
Yeah, I know a few people who have done that.
Yeah, I'm pretty excited for. I feel like of all the programs it could be, that's probably the best fit.
Mm-hmm. Yeah. So what are you looking at doing for like career wise?
Auto tech.
Mm-hmm.
Because
is that what that program is?
what they have So I think they have auto repair and then auto tech and then welding.
Mm-hmm.
And I don't know if you remember, but for my essay last year, one of the requirements for some of the ACE certifications is you need 2 years of either hands-on work experience or formal training.
Mm-hmm.
I'm pretty sure these 2 years would count, so I'd be way ahead of the curve.
Yeah. Yeah, that sounds like a good plan.
Yeah, and I have a meeting tomorrow at 2:30 with the Running Start counselor there.
Mm-hmm.
So we'll see how that goes.
Yeah. So what, you're gonna try to start that next year?
Yeah, because then Running Start will have to pay for both years of it, and I won't have to pay anything.
Yeah. Well, sweet. That sounds like a good deal. I know one of my friends, he ended up going to UTI down in Arizona, and after he graduated from high school, and he worked for a Ford dealership for a while. And I mean, he's the same age as me, and he just started his own business.
Yeah. So one of my friends in Issaquah, his older brother,
Mm-hmm.
was sponsored by Ford and went to Renton Tech as a Ford asset,
Yeah.
and so they had that program too. So if after high school I wanted to do that, I could get into that really easily.
Mm-hmm.
Um,
Were you there? I can't remember. I don't think he came in last year.
no, he didn't. I know what you're talking about though, the UTI guy.
Yeah. Because he gave a presentation one year, and it was pretty good to watch.
Yeah.
But yeah, it sounds like that's good that at least you know what you want to go for, and you're making a plan to do so.
Yeah. Yeah.
I mean, I'm glad I went the path I did, but I thought for a while that, I wish that someone told me I could have just gone to Lake Washington and gotten my AA in welding. But Lake Washington's welding program isn't as good as Bellingham Tech's, so I'm glad that I waited.
Yeah.
Um,
See, that's the big thing. I have a friend who's doing Lake Washington Tech and for this automotive program they have. And he
yeah,
was like, "You're definitely better off going to the nicer school and driving the extra 20 minutes to Renton every day
yeah,
because I guess their facilities are just that much nicer and newer."
yeah. Renton Tech's pretty good all around. Their welding program's really good. Yeah, definitely no complaints about that. The big reason I think Renton is so much better than Lake Washington is that at Renton, that's like their core focus.
Hmm.
And also they have a bunch of industry sponsors in that area to
Oh yeah.
and donate money. So I think that is a big, you have aerospace with Boeing, you've got mechanics for all the different types of manufacturers, and then you have
Hmm.
a bunch of people needing welders in that area too. So
Yeah, it's gonna be really nice because my brother works for Top Hot, and so when you work for Top Hot, you work for the company and not one specific location.
hmm
And he works at the Renton Landing one a
yeah,
lot, and also I know his coworkers, so basically I'll be able to get free donuts and all that good stuff.
yeah. So you can be a good suck up to your teachers.
Oh, I'm talking more for myself because the days start at like 7 a.m.
Yeah, it's not. That's like that's pretty early for like I guess one of you youngsters, but
I mean, no, I'm not saying it's like particularly super early, but plus I have to be there at 7 plus the drive.
oh man,
But it's fine because one of my best friends that goes to Issaquah is doing as well, so I'm just gonna drive to his house and carpool from there.
yeah. Well, it's funny to hear because like when I was working in industry, I had to be like in Ballard, clocked in, ready to work at like 6, and some mornings I had to be clocked in, ready to work at 5. So
Yeah,
getting up at like 3:30 or 4 in the morning to go into work.
yeah. Well, I'm also only 15, so
Yeah, you got all that energy, man. You should be able to get up and just get going. All right, well, sounds good. Have you got any more welding done with those pieces?
no, because there's just been all sorts of stuff going on with like I have to get our roof has been repaired and I had to take down the like awning piece.
Mm-hmm.
So I just haven't really had space or time.
Okay. Well,
It's definitely been on my mind and I'm definitely gonna get back to it soon.
yeah. All right, sounds good.
All right.